Morning Year 10, what we're going to be looking at today is indices, revision of the basic concepts. You should have all seen this type of work before, shouldn't be news to you, so I'll go quickly through the basic ideas and then you'll have an opportunity to go and do some examples for yourself. Indices, revision of basic concepts. What words do you need to know about? Square and cube numbers. Oh, let's just get rid of this off here. Square and cube numbers. Okay, squared number. So we could have 2 squared, 3 squared. You should be happy with those. We could have 2 cubed, 3 cubed. What does that mean? 2 squared is 2 times 2, 2 cubed, 2 times 2 times 2. Okay? You should be happy and familiar with those. The square root and the cube root. So what's the square root of 4? The square root of 4 is 2. What's the cubed root of 27? What multiplied by itself 3 times makes 27. 3 times 3 times 3 makes 27, so the cubed root of 27 is 3. That should be something that you're familiar with. Indices and powers. All that, it's just interchangeable words. Indices. 2 squared. The power is the power of 2. The indices is a 2. 2 cubed. 2 to the power of 3. The indice is 3. Okay? So it's just an interchangeable word there. Reciprocals. Some of you might struggle to remember this. Reciprocal, all that is talking about is if we had the reciprocal of the number 7 is 1 over 7. The reciprocal of the number 11 is 1 over 11. That's all that's meant by reciprocal. Just flipping the number over, okay, and putting it as a fraction. Fractional powers. Fractional powers and negative powers I'll talk about a little bit later on. Let's just get our basic concepts sorted out here. Right, those are our basic rules. Those you will need to write down when we've gone through the presentation. But for now, let's sort out our basic rules in your minds. So our basic rules. Start off with easy numbers so you can see what's happening. 2 squared times 2 cubed. What does that mean? We've got 2 squared times 2 cubed. So 2 squared is 2 times 2. That's then multiplied by 2 cubed. So what's 2 cubed? It's 2 times 2 times 2. What have we ended up with there? 2 times 2 times 2 times 2 times 2. 2 to the power of 5. So 2 squared times 2 cubed is the same as 2, and then 2 plus 3 with the powers. 2 to the power of 5. So that is our general rule. If you've got the same thing raised to different powers but multiplied together, so in this case the same thing is that 2, it's raised to the power of 2, raised to the power of 3, multiplied together, just add those powers, add those indices together, and you get in this case 2 to the power of 5. So in general terms, if you had a to the power of 7 multiplied by a to the power of 3, that would be a, 7 and the 3 added together, which would give us a to the power of 10. So that's your general rule. Just add the powers, the indices together. Very similarly, if we had 2 to the power of 4 divided by 2 to the power of 2. How could you rewrite that? That's 2 to the power of 4 divided by 2 to the power of 2, 2 squared. How do you write that out longhand? 2 times 2 times 2 times 2 on the top, and then 2 times 2 underneath. What can you do when you've got all those 2's on the top line and all those 2's on the bottom line multiplied together? You can do some cancelling out. Cancel that 2 with that 2, cancel that 2 with that 2. What are you left with? You're left with 2 to the power of 2, 2 squared. So what's your general rule? 2 to the power of 4 divided by 2 to the power of 2, 2 to the power of 4, subtract the 2, gives you your 2 squared in this case. So this time, if you're dividing powers of the same thing, so in this case that thing is 2. If you're dividing the powers, if you're dividing those numbers, you just subtract the powers. Okay? So in general terms, go back to using our A. Got A to the power of 7 divided by A to the power of 5. That'd be A, and then 7 minus 5, it would be A to the power of 2, A squared. Just subtract the powers when you're dividing. Okay? Something a little bit different. If you have 2 squared, and then you cube that, so you've cubed 2 squared. What does that mean? It means you've got one lot of 2 squared, 2 times 2, multiplied by a second lot, 2 by 2, multiplied by a third lot of 2 by 2. What have you now got? You've got 2 to the power of 6. So what's your general rule? 2 squared, all cubed, it's the same as 2 squared, and you multiply. You now multiply those 2 indices together, which gives you 2 to the power of 6. In general terms, you have A, you have 4. A to the power of 4, all squared. What's that going to be? A, 4 times 2, A to the 8. Okay, great. Fractional powers. Now I'm going to give you two examples of fractional powers. 4 to the power of a half. Some of you will have seen this before. All that means is 4, and we've made it a fraction. That bottom part of the fraction means that in this case it's going to be a square root. Because that's a 2, it's a square root. What's the square root of 4? It is 2. Second example, 27 to the power of a third. 27 to the power of a third. So this time it's 27. It's cubed root. What's the cubed root of 27? We talked about this earlier on. What's the cubed root of 27? 3 times 3 times 3. Cubed root of 27 is 3. Okay. Let's give you a third example actually. What about 16 to the power of a quarter? So we put our 16 in the root sign, Got that 4 outside. What multiplied by itself 4 times makes 16. 2 times 2 times 2 times 2 makes 16. So the fourth root of 16 is actually 2. Okay? Variation. Common type of examples. What about that? What that means is we take cube root of 27 cube root of 27 and then square it. So cube root of 27, I've already talked about, is 3. 3 squared is 9. Doesn't matter which way round you do that. I chose to take the cube root of 27 first and then squared it. But you could do it the other way round. You could say, right, what's 27 squared? And then take the cube root of all of that. 27 squared is 729. The cubed root 729 is actually 9. So what that's telling you, if you've got a fraction and it's got a number on the top and the bottom, the fraction on the top means you raise the number to that power, so in this case you square it. The number on the bottom is the root, so in this case it's a cubed root. So that's probably quite a useful example, because I've done it 2 different ways there and it's come out as the same solution. So I'll give you another example the same as that, or very similar. So 64 to 2 over 3. So you can do it 2 different ways. We could say 64 squared and then take the cubed root of all of that. What's 64 squared? It's 4096. Cubed root 4096. Let's just make sure we're right on this. We squared it, 4096. Cubed root 4096. Let's just make sure. I'll use my calculator here. Go. Let's do it the other way around. So if we take it the other way around, we could say the cubed root of 64 is the cubed root of 64. cubed root 64 and then square it. Cubed root of 64 is 4. Square our 4 and we get back to 16. Okay, so 2 examples there of this fraction or powers. Okay, 2 more things you need to know. 10 to the power of 1, it's just the number. 100 to the power of 1, it's just the number. 6 to the power of 1, it's just the number. You need to know that, you need to be aware of that. What about What about 6 to the power of 0? Anything to the power of 0 is 1. You need to know that. The reason for that, and let's go back to our theory. If we had a to the power of 7 divided by a to the power of 7, what was our rule of indices? We had to say anything raised to a power, if we're dividing, what do we do with those powers? We subtract them. So it would be a 7 minus 7, which would give us a to the power of 0. You agree? A to the power of 7 divided by a to the power of 7. Our rules that we've been through already say it's a 7 minus 7, a to the power of 0. But we could look at that a different way. A to the power of 7 divided by a to the power of 7. A times a times a times a times a times a times a. Just make sure that's 7. 1, 2, 3, 4, 5, 6, 7. All divided by a times a times a times a times a times a times a. Cancel those out. What are we left with? We're left with 1. So a to the power of 0, anything to the power of 0 equals 1. And that's the proof of why that's the case. Right, these are the rules that you need to write down, ladies and gents. To multiply powers, add the indices. To divide powers, subtract the indices. Working out a power to another power, multiply the powers together. A negative power, I haven't gone through with you. When the power applied is 0, it's going to go to 1. When the power is a fraction, we've divided, we've gone through that, you know what to do with that. It's just a root, okay? You've just got to think about roots as well. So they're your basic rules. I've gone through the basics with you. You should be able to tackle some questions now. Thank you very much for your attention, and I hope that's been useful to you.